Welcome back to another video lesson. Our next logical kind of extension of what we looked at before with algebraic expressions and like terms and unlike terms and how we can combine like terms is this thing called the distributive property. In the distributive property, let's get this little note down first. Today's video is real short. A polynomial can be multiplied or divided by a constant. And we looked at constants in the last video, and we said a constant was any number just by itself, so no letter that goes along with it or no variable that goes along with it. And the result is called, typo there, result is called the expanded form. So we have the expanded form of the polynomial. And when a polynomial is expanded, each term, if you're unsure of what terms are, go back to our previous video. Each term of the polynomial is multiplied or divided by the constant. And this is called the distributive property. This will make a little bit more sense again as we get into an example. The distributive property. And we're going to use this example to start. We're just going to look at some letters. And the distributive property simply says, well, what happened there? There we go. The distributive property simply says we're going to take this constant, which is outside of our polynomial, because inside we have our polynomial, the b plus the c. And we're going to multiply it into, or by rather, we're going to multiply it by each of the terms inside of our polynomial. So if I were to take this, let me erase this so it's easier to see. If I were to take this a and times it by b, well, a times b is ab. If I were to take the a times c, it would be ac. Now let's do it with some numbers. So again, we want to take this constant. In this one, it's 2. We want to times it by 3x. So 2 times 3x, I can multiply the numbers. So I can get 6x. And I can take 2 times 5, and I can get 10. Now for some of you, I'm going to back up a bit. For some of us, we might even want to say, you know what, let's do an extra step. Let's say, well, it's really 2 times 3x plus 2 times 5. And we'll do the same thing. Okay, so 2 times 3x, we've got our 6x. 2 times 5 is 10, and there's our answer. In our next example, we have a trinomial. Remember, a trinomial has 3 terms in it. We still have our constant. Our constant is 3, and it's outside of the brackets. But it works the same way. We still have a polynomial that we want to multiply by a constant. So we're going to distribute that constant into each term in our polynomial. So 3 times 2x plus 3 bracket 2y plus 3 times 5. And we're going to multiply these out. So 3 times 2x, 6x. 3 times 2y, 6y. And 3 times 5 is 15. And we can't simplify that anymore because we don't have any more like terms. We have the same constants, but because these have different variables, they're not like terms. So we can't do anything with that. We can't simplify it anymore. Our last example, -3 is our constant, and our polynomial is 4x plus 1. Same kind of thing, we just threw in a negative now. So -3 times 4x plus -3 bracket 1. I'm going to put a bracket around that thing too, just to make it a bit less confusing. The negative is going to mess us up a little bit, but we'll show you how it works. Well, negative 3 times 4x, negative 3 times 4 is negative 12, so negative 12x plus, I'm going to keep this in brackets, negative 3 times 1 is a negative 3. And we're going to simplify this a little bit, so negative 12x. And we've got a positive and a negative. It becomes a negative. So negative 12x minus 3. And there is our example. Okay, so we've got our examples done. Now I would like you to try some of these on your own. And we're going to distribute the constant. Remember, the constant is this number before, and we're going to distribute it into our polynomial. Once you have these questions done, and we may even want to take these up and look at some of these. You may want to work with a partner to try to figure out some of these. Once you have those done, I'd also like you to look at, here, page 263, exercise 1, 3, and 6. Do those in your notebook or on some paper, perhaps even on the back of the sheet. There should be some room there. And we can look at the distributive property and figure out how the distributive property works. See you in class.